Let's do a quick revision of all the concepts that recently we learned about the similar figures and similarity of polygons. All right. Now see here the questions we have, different questions we have. First question is here: all the circles are congruent or similar? So you should know what is congruency and what is similarity. As we have discussed there, like congruency means exactly the same. If the radius is like here 2 centimeter, you know so another circle also should be exactly of same and having the 2 centimeter. The radius of this 2 centimeter and radius of this also 2 centimeter. So these two circles are, now we can say, congruent in every prospect, in looking and in shape and size, dimension, everything should be same, then they are congruent. They are congruent. But all circles means some circles can be smaller, some circles can be bigger. Now say this has bigger radius, it has a very small radius. So this does not have, these two figures doesn't have the same shape, means they do not have the same size. Though their shape, their appearance is same, but size is not exactly equals, so they are not congruent, they are similar. So all circles are similar. Similarly, all squares are congruent or similar. Yes. Now as you got recently here, like one square is smaller. Suppose all the sides is of 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. Another square is bigger one. Suppose the bigger square, it has suppose 3 centimeter, 3 centimeter, 3 centimeter, 3 centimeter. All the sides, is 3 centimeter. The sides are different. Size of this square and size of this square is different. So since size is different, though appearance is same, so it's not a congruent. It can't be congruent. It's similar. Means having size having different, but shape same, appearance same, size different. Such figures are similar figures. Now all the triangles are similar. Yes. Now if you talk about the sides, any, like if you have isosceles triangle, something like this. Here this has 5 centimeter, here you have 5 centimeter, this is 10 centimeter. Now I'm making another isosceles triangle. Now see here, this is suppose 10 centimeter, this is also 10 centimeter. But if these are 10 centimeter, like this figure can't be, it should be double of that. It's 5 double is 10, 5 double is 10. So it should be, almost double of that, to be corresponding. So if you talk about the isosceles triangle, so it should be 20, and it's not possible to get 20 here. By the way, this is 5 and this is 5, then it should be at least it should be less than 10. It should be 9, suppose. Because what is the reason behind this? Because in triangles, the sum of the two sides should be less than the third side. So if two sides sum is 5 plus 5 10, then it should be less than that. So it is 9. If this is 9, then this will be 18. And there is no possibility of getting this side 18. So that is why isosceles triangles are not equal, are not similar triangles. But if you talk about the similar the equilateral triangles, then it is something like this. See, you have one triangle, it is 3 centimeter, 3 centimeter, 3 centimeter, suppose, and all the angles are 60, 60, 60. And another equilateral triangle you have, suppose this is 10, 10, 10. So if you make the ratio, it will be 3, right? If you make the ratio, what you'll get, like 3 ratio 10, 3 ratio 10, 3 ratio 10. So all the sides are proportional. Everywhere you'll get the ratio of 3 over 10, and angles are equal. So I can say that all equilateral triangles are similar but not isosceles triangle. Similarly here, now this is from the theorem itself, from the definition itself. The two triangles are similar if their corresponding angles are equal. Angles should be equal, but sides should be proportional. And here the two angles should be equal. Like angle must be equal. Then how the figures will look exactly like this is one triangle, all right, and I have another triangle, something like this. This is an obtuse angle and this is an acute angle, right? So see, they aren't looking same. So to look same, both triangles should have the same angles. If it is 60, it should be 60. If it is 70, it should be 70. So they should have equal angles, all right, not the proportional. Like if it is suppose 45 degree and another triangle is suppose 90 degree, and if it is like 30 degree and if it is 60 degree, so no, in that way not. Like, I mean, it should not be proportional, like 45 90 30 60, not like that. Angles should be equal. And two triangles are similar if their corresponding sides are proportional. Yeah, as we had learned initially. So triangles will be similar when their sides are proportional, as we did here. Like, in this triangle, the sides were proportional. How? See here, the side was 3 here, 1, another were 10, 3 10, 3 10, everywhere all the sides are proportional. You'll get the ratio 3 over 10. So that is why you can say now that when the sides are proportional, then corresponding the two triangles will be similar. Now if the sides are equal, then also it is, I don't know, I'm not that much happy with the given answer. Actually, I've copied from some book. one of my textbook. In the place, putting equal, it's not that much satisfaction, because like I have a equilateral triangle here, right? This is of suppose 4 centimeter, 4 centimeter, 4 centimeter, right? And this is 5 centimeter, this is 5 centimeter, this is 5 centimeter. These are similar, right? These are, everybody can say these are similar. But if it is 4 and 4 and 4, what it will be, like, to be a similar, what is our main condition? That all the angles should be equal. Now see, here is also angle equal, here is also angle equal, here all the angles are equal, all the corresponding angle they are asking the Stephen, like this corresponding angles are equal, you know if you see another angle is this one, this angle and this angle is equal, and the third angle is equal with third angle. So all the angles are equal and sides are also equal. So what happened? These are still similar, but you can say it is a special type of similar, and those similars, when exactly one figure is going to equal with another figure, that becomes a congruency, right? That becomes congruency it becomes. So congruency, right? So I mean, what I can this right? Congruency. So but all the congruence figure, we can say similar figures, all the congruence figure are similar figure, but all the similar figure are not congruence figure, something like that, well, we'll be talking more about when we'll be learning more when we'll talk about the congruency. Okay, now next point is here, like, two polygons of the same number of the sides are similar if they are corresponding. Here, two polygons of the same number of sides means if it is pentagon, another should be also pentagon. If it is hexagon, another should be also hexagon, something like that they are asking, right? So two polygons of the same numbers of the sides are similar if their corresponding angles are means first choice you need to say angles should be what, equal, yeah, and their corresponding sides should be proportional. Exactly, it is given in the order, right? So their corresponding sides should be proportional and angle must be equal. If you have like pentagon here, like if you have suppose two pentagon, one here and another you have, then you should have to get like equal angles and equal everything, I mean, your all angles should be equal and the sides should be proportional. Like if it is like suppose if it is x times, then it should be something m times x. If it is like y times, then it should be again m times y, right? And like if it is z times, then it should be m times z. If it is like p times, then it should be m times p. If it is centimeter, suppose the measurement of this is suppose s, then it should be m times s. It should be in certain ratio. I hope you understand, and I'll be doing one or two more exercises. After that, we'll jump for the similarity of the triangles. All right, and we need to learn many theorems are there, and those are really important. Okay, we'll be meeting in the next video. Goodbye.